So okay. Yeah, I'm Tao Huang from UC, and first let me introduce give some brief introduction of the competition and about our AUSLAN daily dataset and the tasks. So first, the AUSLAN daily dataset is about sign language translation for the daily communication and the news in Australia. And in this introduction, I will first show the background of the sign language translation and the motivation of this coding festival, this challenge, and the tasks. And also, we will introduce some details about the AUSLAN daily dataset in this competition. Then we will show some definition of the text and how to show some examples of how to design the algorithms on the sign language translation. And finally, I'll give some suggestions for getting higher scores in the competition. So the first one is the background. Currently, the hearing loss and deaf is a quite emerging problems in all around the world. For example, the World Health Organization in April 2021 shows that we have over 5% of the world's population require rehabilitation to address their disabling hearing loss. And that contains about 432 million adults and 34 million children. And by 2050, there will be over 700 million people that will have disabling hearing loss. And in Australia, according to the Hearing Care Industry Association, in 2015 June, it shows that about 1 in 6 Australians suffers from the hearing loss, and this is expected to rise to 1 in 4 by 2050. So it's an emerging topic in the hearing loss. We need to solve the society problems to improve this problem. So next, I'll introduce the motivation. The motivation about our challenge, the sign language processing, is because the deaf and people with hearing loss will face problems more easily than normal people. For example, for the children, if they face the hearing loss problem, they will probably drop out of the school. And for adults, they will lose their jobs. And also, mentally, they will feel lonely due to the social isolation. And since the sign language is what they can only use to communicate. So to solve the above problems, there are two methods. The first one is to improve the medical level. And the second one is about our challenge. We can use some modern technology to help the deaf people to integrate into daily life. For example, we can do some sign language translation to help the people to translate the videos, to translate the sign languages into text, into English. So the sign languages are some visual languages which convey information by the signers, hand shape, or some facial expressions and body movements and so forth. So next I'll introduce the AUSLAN daily dataset, which is a major component of our festival. The dataset is the primary way for deaf or people with hearing loss to express themselves. Similar to various spoken languages, the sign languages have their vocabularies and grammar. And according to the geographic regions, different regions usually have their native sign language, even though these regions share a commonly spoken language, such as English. For example, in America, in Australia, and in the UK, we have uh, different vocabularies of different signs of the sign language. And for in Australia, there is no publicly available large-scale AUSLAN dataset for continuous sign translation. So this is the importance of the AUSLAN daily dataset we introduced. So for a brief introduction of the dataset, first it combined with two subsets. The first one is the AUSLAN daily communication. It contains some video clips about the daily communication. It is majorly from the daily and Pulsar videos. And the second subset is about the AUSLAN daily news. It contains the videos from the news in the television. Here's some video clips for the daily communication subset. We can say it may contains multiple scenes in our daily communication and usually contains multiple persons in the video. And the second one is the AUSLAN daily news. It is more like the news scenes in showed in our televisions in the news video. And usually in the daily news dataset, we'll have a signer to show the sign language, which would be more officially and more accurately. And we also show the diversity in our AUSLAN daily dataset. We can see that the videos in the dataset contains multiple topics. For example, the technology, the education, sport, social, environment. So it is a very diverse dataset. Adding the AUSLAN daily dataset, we have a two-stage data labeling procedure to annotate the videos. For example, the first is at first we use the experts in AUSLAN to align the video clips and its transcriptions. For example, for a video clip, we will let the expert to annotate their corresponding transcripts or the subtitle. And also, we have annotators to detect the signer in each aligned video clip. For example, we can see the previous examples. In each video, we will have multiple persons in the video. So we to detect, to translate the sign language, we also need to find out which person is the signer to show the sign language. So the second step is to use annotators to detect the signer. And according to this two-stage procedure, we will obtain a dataset with a various fine-grained annotations. For example, we have 2,000 videos with its finger spelling pairs, and 3,000 video with gloss pairs, and 25,000 videos with sentence pairs, and with around 46,000 whole sequences of people. And here are some comparisons with our data set with other data sets in other countries. Uh, Basically, the previous data sets usually contain one person in the data set in the video, but in the AUSLAN data set, we contains multiple people in the video, and it will be more challenging for the sign language translation. Then I'll give some overview of the AUSLAN daily tasks that we can conduct it on the AUSLAN daily dataset. The major tasks in the dataset is the sign language translation, and according to the dataset, it contains the single person translation and multi-person translation. And also we will have some more detailed tasks such as the sign spotting, the finger spelling detection, and some sign detection, and isolated sign language recognition, and sign language alignment. We will introduce these tasks in the next slides. The first one is the multi-person sign language translation. Like previous discussed, in the video of our data sets, we will contain multiple persons. So the multi-person SLT is to translate the sign language to the ground truth, to the English, by detecting the language in the multi-person video clip. And another, we have a easier task, which is single person SLT. According to our annotations of the signer, we can group the signers to obtain a video clip with only single person, with only the signer. And the task is the same. We need to predict the language according to the sign languages, according to the video. So here are some examples of the video. So given a video clip, we need to predict the subtitle about the video, about the sign languages. And this is the single person examples. And here are some other tasks we will not use in the challenge, in the competition, but it's worth to discuss. And in this data set, we can use these tasks to explore more possibilities in the application. And the first one is the sign spotting task. It needs to first detect the location, the time steps, the time duration, which in which one gloss is occurred. And then if we identify, if we locate the sign clip, we need to detect the type of the sign. We have a open source sign bank, and then we will need to align the video signs to the sign bank to identify which type of the sign is in the sign bank. For example, we have an open source sign bank shows the standard cake sign, and then we have a video clip to show the cake like this. So we need to identify the cake according to the video. This is the sign spotting example. And the second one is more detailed. in the character level. It's about the finger spelling. The finger spelling is to use use the fingers to spell the words. So in this task, we also need to find the duration of the finger spelling, and then we need to split the finger spelling into multiple frames and detect their according words, their according characters. The next is the signer detection task. In our video, we have multiple persons, so it is important to detect which person is the signer. So it's more like an object detection task to find the location of the signer. Yeah, here are some example. After the detection, we will find out who is the signer, and we can group the signers to get the video with single person. The third one is the isolated sign language recognition. The isolated means that we don't need to translate the whole language, the whole sentence, but we can segment the videos and detect and recognize the glows one by one. So this is isolated. And then the next one is the sign language alignment. In this task, we need to identify, we need to locate the time step, the time of the sign language in the video. For example, we given a language about LLY, we need to locate in which time the LLY occurs in the video. And here's the summary of the AUSLAN daily dataset. The AUSLAN daily dataset is the first large-scale AUSLAN translation dataset. And AUSLAN daily has two main features. The first one is the topics. The topics are diverse and signed by multiple signers. And the second one is about the things. The things in our datasets are more complex. We have the daily communication videos and some news videos. This is diverse and complex. And also, the AUSLAN daily provides multi-grand annotations. Like we have the sentence level, we have the gloss level, we have the finger spelling level. This can help researchers to investigate a variety of tasks. And the next is our major part. We will formally introduce how to do the competition, how to do the sign language translation task in our dataset. There are multiple types of the sign language translation methods. The first one is called continuous sign language recognition or the sign language translation. In this task, it will use the gloss to represent the video. So given a video, it first translates the video into the glosses, which is the sign. It is about the sign language. For example, in the first clip, it shows a smile gloss, and the second is the youth. The third is 17. And after getting the glosses, to get the final English translation, we need to use a machine translation model to translate the glosses into sentence of English. This is a process of the sign language recognition with glosses. Yeah, and usually the training process, which contains the sign language recognition and also the neural machine translation to translate the sign language into English. They are trained end to end. Okay. And also we have gloss-free sign language translation, which means that we do not need to translate the video into glosses, but we can directly translate the video into the English. And since the AUSLAN daily dataset does not contain the continuous glosses annotation, so the task in our competition is more about the gloss-free, which means that even a video, you need to directly translate the video into the final output, into the final English sentence. Uh, uh, for the gloss-free, why we didn't contain the gloss annotations, it is because to obtain a large-scale sign language with continuous glosses, it is costly and time-consuming. For example, if we wanna annotate an hour of continuous sign language, it requires an expert who is proficient in sign language, and it will cost him approximately 10 to 15 hours. So it is very time consuming. And also the model is hard to apply to other sign language datasets and do not contain the gloss annotations. So without the continuous gloss annotations, here's the key statistics of the dataset. We can see that in the dataset, we contain videos with 1080p resolutions and 25 FPS. And also we have three major datasets. We have three subsets, which is the chain development and test sets. And also there contains a large number of segments in the dataset. For example, we have around 12,000 segments, 12,000 videos in the training dataset. So in the next, I will introduce some basic model that can for you to use in the competition. The first one is the basic SLT model architecture. It is from a paper in CVPR 2020 for the joint and end-to-end sign language recognition and translation. In this paper, in this method, in this model, we will take the video clip or video frames as the input and use a convolutional neural network to encode the image features into the latent feature. And then we will use the encoded feature as the input of a language model. And this language model will predict the final English output. This is our final translation results. Like this, we have embedding or encoder or video encoder to encode the video frames into features. And then we will have an encoder to further encode the feature, to further extract the features in the video. And then for each frames, it is inputted into another model called decoder or a language model to predict the final language output. And for training the network, we will use the cross entropy loss. And in the cross entropy loss, the X is about the source language or the predictions of our network, and the Y is the target language, which is the subtitles in our dataset. And the evaluation metric contains the blue 1, 2, 3, 4, and we will use blue 4 for ranking the competition. For example, if the evaluation of blue 1 is about to segment the whole sentence into word level, and it will compare the predictions and the original annotations to compare their differences. Yeah, this is a detailed computation of the blue score. And except the previous shown gloss-free translation, we also have another type of method to do the translation, which is called pose-based translation. In this task, we majorly first detect the key point of the person and the fingers, and then according to the locations of the points, we can identify which sign or which gloss the person is expressing. So in these tasks, we will use the post locations to detect, to predict the final language. And also the second one is about the RGB based representation. It is more like our previous framework, like this one. We will use the original RGB image as the input to get its feature. And then we will put this feature into another language model for the predictions. And here are some baseline comparisons of these two type of input. We see that the post input will obtain much better performance compared to the RGB ones. And finally, I'll give some suggestions about the competition. First, for the video embedding, embed the video into features. If you use the post-based method, you can choose a more accurate key points estimation model. Otherwise, if you use RGB-based methods, you need to find some word level sign language datasets for pre-training, and this would this would lead to better performance. And for the model design, you can use the STGCN, which is a model about using graph convolution neural network to enhance the translation performance. And also you can find some fusion models which contains the not only the image feature, but also the language features. This would have more have better alignment to different modalities. Yeah, that's all for the introductions of the dataset and the tasks. And thank you for participating in the USYD Coding Festival 2024. Thank you very much.
Yeah, thank you so much, Tao, for that insightful introduction to the AI for AUSLAN challenge. It's truly inspiring to see how we can leverage AI technology to bridge the communication gap and make a positive impact on the deaf and hard of hearing community. Next, I'd like to introduce Guangxi, who will walk us through the baseline code. This will be a crucial part of your journey in this competition, providing you with a starting point for developing your AI models. Guangxi, please take it away.
Hi, hello everyone. Can you hear me?
Yes.
Okay. Welcome to wait a second. Welcome to the AUSLAN daily competition. This is a task of automatically translating signs from the video sequence to natural language, which has been introduced thoroughly by Tao. Thanks a lot. And now I'd like to introduce the data set for AI for AUSLAN, this competition. In this competition, we'd like use AUSLAN daily communication as the data set. The data set is from a TV series named Sally and Possum, and the total number of the sign video clips is around 14K, and the total number of the signers is around 50. Here's some samples of the data set. And today the content can be divided into 4 main parts. Let's go look at the first part, the dataset download. Actually, we can download the dataset through this Google Drive link, and here are the files in this Google Drive, and I will introduce the details of these files a little bit later. And then let's look at the codes. First, we'll load some packages, and here's are some help functions. And after data split, we can see here we have around 30,000 and 241 training video clips. And here's 3 columns: the video, the name, and the subtitle, and the LAM subtitles. The subtitles are the means the English natural language text of the corresponding signs. And the lemma subtitles, due to the sign language lacks of tenses and the plural forms, so we will perform lemmatization on this subtitle, and which is used to training and is what we need to predict. And now here the text data include 800 video clips, and the inference is what we need to predict. And next, the feature format. Actually, we provide the 2 types of the feature format for you guys, and if you want to use these features, you don't have to start from the raw video clips. You can only start from these features. So the first is post-based video clip features, and as mentioned previously by Tao, I think we have quite an understanding on it. So let's have a look at the example. Here, the gloss is the name, and it's a gloss is -1, which means we do not have any gloss on it. So we do not use any gloss. And the text here is, I will go and see. And the number of frames is 20, and the signers is 1. And here is the features. And for the text, the text is -1, and which is what we need to predict. And next, for example, the alpha pose is an accurate multi-person pose examinator, and to match poses that correspond to the same person across frames, we also provide an efficient online pose tracker called Pose Flow. As we can see, and intuitively, several key points are set to the bodies and to the hands to track the like the move and the actions of the certain person. And we can do some post visualization here. As we can see on the left, it's a RGB frame, a single frame, and the post features of this frame is on the right is about this. Is like these features. So we can use it to train the model. And the second is RGB-based video clip features. Different from the pose-based features, it use we fine-tune i3D on the word level sign language recognition data set and extract sign video features with different window width and strides. And here we use the window width of 16 and the stride of 2 to extract the features, and the formula is here. The dataset format is same as the post features, and I will introduce how to use them a little bit later for the code part. And next, the baseline code. Let's record two types of classic method of sequence-to-sequence architecture: the RNN-based framework and the transformer-based framework. RNN is a classic sequence model which is designed to handle the sequence data. So it is well suited for sequence-to-sequence tasks like machine translation here. And here is the figure. So we input some original language into the encoder, and the information is saved at the hidden states and will be passed through time steps. And the information will also pass to the decoder, and the decoder is used to generate the prediction. And the second architecture, the transformer-based architecture, is also designed for machine translation originally. And as we can see, the inputs is several frames, and the frames are input to the CNN and to capture the spatial information, and then the features is fed to the encoder of the transformer, and here's the self-attention and the residual connection, and the information is also passed to the decoder as the value and the key. And the decoder is also used to generate the prediction. So it's two types of architecture we can use. Okay, next is hyperparameters. For the hyperparameters, I'd like to introduce two important hyperparameters. The first is features. As I mentioned before, we can use RGB or use a post-based features. So you can choose anyone you like. And for the model architectures, we provide RNN and the transformer. And then is any other hyperparameters like learning rate or batch size or something like that. You can try to use different of that hyperparameters to test the performance. And for the post-processing bin search is a method for decoding a sequence given an autoregressive function that output a probability distribution over the next possible symbols. In one word, is used to generate the most probable output. And for the evaluation blue score, here we provide an example for this blue score, how to compute the blue score. And we use blue 4 for ranking the computation. And then with and for those who do not have enough GPU resources, we provide two solutions. And let's move here. Let's first introduce the file we provided. And here, the Google Drive. This is the introduction slides, and this is our files, and the codes is used for train and the test and the translate. Here. And the data split is the train data and the test data and the corresponding CSV file. And if you only want to use the features we provide, you have no need to download this unless you want to generate more useful features. And here is features. Two types of features: post-based features and RGB-based features. And here is a Jupyter notebook. The first is introduction notebook. This one, and this is a Colab environment setup introduction notebook, and you can open it here and follow the instructions step by step. So first, you have to mount your Google Drive. Before that, you need to make sure you have added the shortcut of the Coding Fast on your own Google Drive. And after connect to the Google Drive, and you unzip the files, and here install some required the packages and install. And okay, after you install all the requirement packages, you can train the model. The default epochs is 100. You can feel free to change the epochs in the YAM files here. So you can for this file, I'd like to introduce. This is data part. You can change the data path, or you don't have to change. We have set it already, and you can change the feature here. You can use the two types of features and changes to another changes to like this hand, body, or face. These three. And for the testing, is the hyperparameter of the bin search. And for the training, here you can change some hyperparameters like the learning rate, like optimize and the bench size and epochs and something like that. Weight decay if I have time to test. And for the model, for the model, sorry, maybe, let's move back here. For the model here, it's an initializer and the embedding initializer. You can change the model architecture here. For the encoder, you can change it to RN or the transformer, anything you want. And you can change the layers. You can scale it to like 12 layers. The larger model maybe may get better performance, and you can change these hyperparameters. Okay, after set all the hyperparameters, you can train the model here. This code to train your model. After a long time waiting, you get your well-trained model and you run this code, the test and the translation step by step to get your own final result. The result will be saved to this direction, and you need to download this file to submit. And I have already download my own CSV file, and I will show you how to submit the result. Back to this page, after you log in and you click the submit and submit your and select the file and submit. I can show you. Here. After submit, you will receive results, and this one, the blue 4, is what we use to rank your what we use to rank. Okay, this is for the Colab, and for another GPU resources, the Kaggle, we have the quite similar solution, and on here. You upload this notebook to the Kaggle and add the input. The dataset is AUSLAN data. After you add in the input, you also need to run this code step by step. And here is this code is used to change your hyperparameters. You can also directly change the hyperparameter in the file. And then also train and test and translate and get the final results of your own, and download your own result and submit, and that's it. That's that's a code part, the code usage and submission. And I've showed how to submit your results. And for the future suggestions, two main part, the video embedding. As I mentioned before, we provide two types of the features, the pose-based and the RGB-based. If you want to generate better features of these, you can like use a more accurate key point estimation model, or use another word level sign language data sets for pre-training. Also, you can extract another meaningful features instead of these two. And for the model design, you can try any other models. And here is the references. Please feel free to ask any questions. That's all. Thank you.
Yeah, okay, thank you, Guangxi, for that detailed explanation of the baseline code. I hope this tutorial have given you all a good foundation to start your project. Remember, the deadline for the submission has changed to Friday, 19 July 2024, so make sure to use your time wisely. If you have any question or any further assistance, feel free reach out to us. We will also be uploading a recording to this tutorial on our website. Thank you again for joining us today. Good luck and happy coding.
Sir, may I ask you a question out here?
Yes, please.
What are the criteria for the competition, sir? Based on what the evaluation will be done?
The evaluation.
Yes, sir. What are the criteria for the competition?
Graduate students? Maybe 10. Yeah.
Yes, sir. I cannot get you clearly.
Yeah, sorry.
What are some of the criteria for the competition? So will you be evaluating based on the code accuracy, or what are some of the criteria that you will be evaluating us?
We only use the blue for evaluate the result. Is this answer your question?
Yes, sir. Okay, sir. And then
Yeah.
next thing is, when will the result declaration be done for the coding fest?
Sorry?
The result, when will the result be declared?
We'll update the leaderboard every day. Yeah.
Okay, sir. That means on 19 we just need to submit. No need to do presentation and all, right, sir?
Yeah. If you rank in our top 3 in this competition, you will need to make a poster and present your solution. Yes. Okay.
And then, is there any restriction for the module that we are going to use to develop the application?
Yeah,
So
yeah.
we can use any model, sir, or is there any
Yes,
restriction?
you can use any models. Yeah. Any question? Okay. Okay, thank you all. Bye.